Hello friends, in this lecture we are going to discuss about various types of diode. We are well known about various types of diode. Basically there are four types of diode. First one is PN junction diode, then second Zener diode, third light emitting diode, fourth photodiode. Among that, in this lecture we are going to discuss about Zener diode. Zener is one of the special purpose PN junction diode and its main application is as a voltage regulator. Zener diode are special kind of diode which permit current to flow in the forward direction. What makes them different from other diode is that Zener diode will also allow current to flow in reverse direction when voltage is above the certain value. In this slide, we can see physical structure of Zener diode. It is two terminal, two layered single junction semiconductor device and symbol is shown at lower side. It has two terminals, anode and cathode. Terminal taken from P side is called as anode and terminal taken from N side is called as a cathode. When P is connected to positive, then it is called as a forward biasing, and N is connected to negative, then it is called as a forward biasing. When opposite connections are made, then it is called as a reverse biasing. See the connection of Zener diode as a forward biasing mode. Here anode is connected to positive terminal of battery and cathode is connected to negative terminal of the battery. This configuration is called as a forward biasing of the Zener diode. When Zener diode is forward biased, it operates as a normal mode. In forward bias, P side connected to positive, N side is connected to negative. In this case, electrons and holes swept across the junction and large current flow through it. Means this work like an ordinary diode. But Zener diode is popularly used in reverse biasing mode. This is circuit arrangement for Zener diode as a reverse bias mode. In case of reverse bias, current partially zero and certain voltage which is called as a Zener voltage, the current is increased sharply. Each Zener diode has breakdown rating which specifies the maximum voltage that can be dropped across it. Means as a voltage regulator, we can use Zener in reverse biasing mode. And reverse bias breakdown voltage, that is reverse breakdown voltage, can be decided by adjusting doping level. This slide shows characteristics of Zener diode in forward bias mode as well as reverse bias mode. In forward bias mode, characteristics are drawn in first quadrant. These characteristics shows forward voltage and forward current, and when we will observe the characteristics after cut-in voltage, current will increases rapidly in forward bias mode. But in third quadrant, forward voltage and forward current both are shown in third quadrant because both are connected in reverse biasing mode. Means after breakdown, current rises rapidly. That current is called as an avalanche current. Means after avalanche breakdown or Zener breakdown, current will increases rapidly. Then applications of Zener diode as a voltage regulator. We know that Zener is used as a regulator when it operates in Zener region. Then another one is light emitting diode, LED. Light emitting diode is one of the special purpose PN junction diode which emit light when it is forward bias. It is also semiconductor type diode and physical structure of LED is shown here. It has two terminals, anode and cathode. Anode is positive and cathode is connected to negative polarity of the battery to emit the light. Basically, anode is long and cathode terminal is short. for indication purpose. Means to connect the LED in circuit, long terminal should be connected to positive and short terminal should be connected to the negative. Now how it works? When current flows across the diode, negative electrons move one way and positive hole move other way due to the polarity of the battery. This structure shows the movement of electrons and holes due to connection, that is due to battery polarity. The holes exit at the lower energy level than free electrons. Therefore, when free electrons fall, it loses energy. That is shown in the lower diagram. We know that always electrons are available in the conduction band and holes are available at the valence band, and there is energy gap, energy difference between valence band and conduction band, and after recombination they will emit the light in, that is excess energy in the form of light. Now how LED will work? This energy is emitted in the form of photon which causes light. The color of light is determined by the energy gap inside a light emitting diode. Now LED consists of various parts. That inside structure, it consists of inside a light emitting diode, emitted light shown, diode, then its segments. Inside structure consists of P and N type semiconductors. Kind of LEDs. These are various kinds of LEDs shown in the figure. Now how to connect the LED? It requires 1.5 to 2.5 volt supply and current near about 10 milliampere. To prevent overloading, use resistor 470 ohm. This is suitable value for connecting LED in the circuit. This is a circuit arrangement with resistor and symbolic representation of LED. Then introduction about LED. LED goes revolutionize light technology of modern era. Fourth and latest generation of light sources. The white LED lamp is equivalent to 60 watt incandescent lamp in size of brightness but lasts 25 times longer, run on less than 10 watts. Construction of LED. This is actual structure of light emitting diode. From upper side it consists of epoxy case, then wire bond, then reflective cavity, semiconductor, then lead frame and flat spot at the lower side, and terminals are taken as a anode at left side and cathode at right side, which is connected to negative, and anode is connected to the positive. The LED consists of chip of semiconductor material dropped with impurity to operate as PN junction. The chip are mounted in a reflecting tray in order to increase the light output. The contrast are made on the cathode side by means of conductive adhesive. Now working principle of LED. The LED is semiconductor diode that emit light when current passes through it. A N side is heavily doped. When forward bias, the built-in potential at the junction is reduced. The electron from N side get injected into P side. Electron combine with hole resulting in emission of photons, that is light. This effect is called as a electroluminescence. This is structure when LED will emit the light. When P is connected to positive terminal and N side is connected to negative terminal of the battery, due to the repulsive force on holes and electrons from outer side, they will come together at the junction and recombination of electrons and holes will take place. We know that due to energy difference between electrons and holes, excess energy is emitted in the form of light, and that excess energy we are shown from the semiconductor diodes in the outside world. that is emitted light. And various applications of LEDs are shown in this slide. First application in mobile phones as an indicator, then sign off displays as an indicator in automation or automotive applications, then as a signal source in various applications, then for illumination purpose or as an indicator purpose in various applications. Basically, LED is used as an indicator. Then last one diode, that is photodiode. A photodiode is semiconductor device that convert light into current. Basically, this diode is also connected in reverse bias mode, and when light incident on it, then current will flow through this device. This is also one of the PN junction diode special purpose, which is manufactured to detect the light. Then introduction about photodiode. See the following schematic diagram of photodiode. It consists of anode and cathode, and light incident on it is shown. This is symbolic representation of photodiode. Under the forward bias condition, conventional current will flow from anode to cathode following the arrow in the diode symbol. Photocurrent flow in the reverse direction. Means when this is connected in reverse bias or reverse bias fashion, then it will detect the light and proportionally current will flow through the device. Then introduction, that is what is photodiode. Photodiode is semiconductor light sensor that generate current or voltage when the PN junction of semiconductor is illuminated by light. A photodiode is type of photodetector capable of converting light into either current or voltage. Depending upon mode of operation, the common traditional solar cell used to generate electric solar power is the large area of photodiode. Means in solar cell, photodiode is popularly used to detect the light and convert it into proportional current or voltage, which is stored in the form of batteries. Then photodiode construction. From upper side, there is metallization. Metallization is used to connect the leads, and after that SiO2 is shown. Then P type semiconductor, and below that N type semiconductor, that is PN junction or PN junction, and depletion region is shown in figure, and at the bottom side there is metallic contact. Then working of photodiode. When photodiode is connected in the circuit, basically anode is connected to negative terminal of battery and cathode is connected to positive terminal of battery, because this diode is used to detect the light. Basically this should be connected in reverse bias fashion, and when light incident on it, then current will flow through the device. This is working principle of photodiode. A photodiode is PN junction diode. When photon of sufficient energy strike on the diode, it excite an electron, therefore creating the free electron, that is electron and holes, that is charge carriers will be generated. This mechanism is also known as inner photoelectric effect. If absorption occur in the junction depletion region or one diffusion length away from it, these carriers are swept from the junction by built-in field of the depletion region. Thus, hole move forward the anode and electron forward the cathode towards the cathode, and photocurrent is produced. This photocurrent is sum of both dark current and light current. So, dark current must be minimized to enhance it. Last, that is applications of photodiode. Photodiodes are widely used in numerous medical applications like instruments to analyze sampler detectors and computerized tomography, and also in blood gas monitor. These diodes are much faster, more complex and normal PN junction diode. It frequently used for lightning regulation in optical communication. In solar cell, it is used to generate the electricity or to charge the battery. Thank you.